This video is going to focus on how to build a confidence interval and where do we start when we're trying to build a confidence interval. So let's say that we are talking about this urgent care, that the mean number of patients per hour they're able to receive is 16. And let's say that the sample is fairly large sample. We have here about a sample of 40 hours. So how would I know how reflective this is of the general mean of all the hours that this urgent care is open? Well, I'm going to look at the sampling distribution of X bar. Now remember that sampling distribution of X bar, even if they didn't tell me anything about the parent population, if the N is large enough, we can employ the central limit theorem and know that the sampling distribution of X bar is actually going to be normally distributed with mean mu. Now this population parameter, I do not know, but I know it's going to be there. And the mean of X bar is going to be right on the population parameter. And that's, remember, is the unbiasedness of our estimator, which is why we use X bar and we love it. Now, all along this x-axis over here, these are all values of X bar. The values that are closer to the population mean are more likely to happen, right, on both sides. And the values that are further away are less likely to happen. Their probability of happening is much lower, okay? So as we are trying to build our confidence interval, it's important to remember that we are estimating our mu. Well, if I am looking, if I want to estimate our mean number of patients, I'm going to use my point estimate, and I am going to use also the standard deviation. So if you remember, the empirical rule says that within one standard deviation away from the mean, we're going to have 68% of the population, or 68% of X bars are going to fall in between one standard deviation. 95% is going to be between two standard deviations, and 99.7% are going to be within 3 standard deviations. Well, if I am interested to know if I would like a 95% confidence interval, okay, then that would mean that I would move 2 standard deviation left and 2 standard deviation right. And that would be capturing the mean 95% of the time. The CI stands for confidence interval. Okay, how do I get it? I take my point estimate, whatever that is, my point estimate, and I'm going to add 2 standard deviation one time and get the upper limit. Okay, this is this guy over here. Right, and I'm going to take another time, let's do this in a different color. I'm going to take my point estimate and I'm going to subtract 2 standard deviation, and I'm going to get the bottom boundary of my confidence interval. Okay, and this is how we're going to get our confidence interval. Now, if I also knew that the standard deviation of this practice happens to be, I don't know, plus minus 2 patients, okay, for these 40-hour samples of patients in the practice, then what I would do there, I would simply do 16 plus minus twice. I should probably have taken a different number. Let's make this a 3 patients per hour. Okay, let's make it 3 patients. So I would take twice standard deviation, subtract it, twice standard deviation, add it. Okay, so my mean, my actual mean is going to be within 10, so 16 minus 6, that's 10, and 16 plus 6, that's going to be 22 patients. So my confidence interval is going to be anywhere, for my mean, is going to be anywhere between 10 and 22 patients per hour. In the next video, we're going to talk more about the critical value. How do I figure out this 2 over here? Okay, how do I go from 95% to this 2 minus and 2 plus.